It should be recording now. It says in
Yeah,
progress.
AI lady just let me know.
Yeah.
Okay. Well, my name is Brett Estrad. I'm a member of Houston Perl Mongers, now the leader, and I'm going to be talking about prototypes. And the title of this talk is based off of a very old but super useful write-up by Tom Christensen, who is one of the originators, original Perl gurus. I think even back into the late '80s when it was first starting, and he's more or less dropped out of the community at this point, but so have a lot of people. But a long time ago, he wrote something to P5P discussing what's wrong with prototypes. And so when I was doing some work on using prototypes, or I became interested in it, and I'll talk about that shortly, why, I found his article, and it was super informative, and it really helped me out. And there was one key phrase at the very end of it that if he would have just started off with this, it would have explained everything almost immediately to me about what are prototypes. And what he did was he called them, he said, prototypes are just parameter context templates for implicit coercions. And so I'm going to talk about initially what that means, but we know them more colloquially as prototypes. And but ultimately, this differentiates it very well from, like, say, something modern that we have now called that we call signatures. Okay, let's go. So what does that mean? Parameter context. Parameter context simply means that it's in the context of subroutine parameters. Okay. And so that's pretty straightforward and easy to understand. Template is exactly what you would think it is. It is a declarative description of what it should look like. And so that's why you get all you'll see some examples coming up, but I want you to think about the prototype description as literally just a template. Like we're used to working with, templates with HTML or text documents. We're used to using templates, more or less templates, when it comes to like printf or pack, something like that, where we're describing declaratively, like, this is what we want it to look like. And then implicit coercion means that what is being passed in the parameter context, or as parameters through the subroutine call, are going to get matched up based on position, and Perl is going to try to coerce it into something else. So you are describing visually, declaratively, how you want Perl to force what you're passing it into something else. And a simple example is here. So this is a coercion of a lexical block into an anonymous subroutine. And so the way that we have the subroutine, can y'all see my mouse cursor? I'm
Yeah,
moving.
absolutely.
Okay. Okay, cool.
Yeah, sorry, I had my mouth.
Oh, no, that's all right. Okay, so this is a subroutine definition like we're used to, with the addition of this prototype. And this prototype, it's an ampersand, and ampersand in Perl is associated with other things, but mostly it's associated with subroutine references in Perl. And so it matches up with other data types. But what we're saying here is this subroutine definition, where it's expecting you to pass in something that can get turned into a subroutine reference or a code ref. And in the case of just the single ampersand here, you can actually pass it a lexical block. So just stuff that is contained within the curly braces, such as down here where I'm calling it. And that will get, when it gets passed through the Perl, the Perl interpreter, the Perl will force that into being whatever magic has to happen. That block will become the body of a code ref. Okay. And so what you have here is the subroutine definition is it's getting passed in the one parameter, and I have it called code ref. So you're going to pass it in a lexical block, which is down here. It's going to get converted into a subroutine reference. And then I'm just using the normal shift idiom here to capture it. And then I'm going to be running that now code ref as using the deref syntax here. So what I can do is when I call it run block as subroutine down here, I can just write the name of the subroutine and then immediately after create a lexical block. And within it, I can consider that a subroutine. And so when I actually run the code down here on the bottom right, I'm just running it using the Perl command. It's going to print out 42. And so you see one subroutine definition up here, but you don't see it anywhere else. Well, this ampersand prototype here, it is forcing this lexical block and giving it all the magic bits it needs in the interpreter to become a code ref. And then when you use this dereference syntax here to run the code ref, it's going to run that as a subroutine. And so this is a it's a very good example of what we're dealing with. And from this point forward, all we're going to be doing is adding additional like symbols within the parentheses, positional parameters with coercion parameters within the parentheses, and showing how you can actually pass in parameters and capture them within, say, these lexical blocks that then get coerced into being subroutine references. This is a more complicated example. So the subroutine I have defined up here at the top, run block is subroutine with parameters. If I'm going to go back one, if I try and run this and add a comma down here and then some other parameter, the subroutine, it will not be available to the subroutine. So even if I change this first line here to capture what I think is a second parameter, it's not going to be getting passed in because it's now using prototypes, and that anything after this subroutine or this lexical block coercion into a subroutine ref is not going to be captured. But you can add an additional declarative positional symbol here, which is the @ symbol, and that is just generally expecting a something to get coerced into an array, and then you will have then additional parameters to run the code. And so what's going on here is I'm passing it in. It's building upon the previous example. I am sending in this lexical block down here, and the additional okay. So I'm sending in, when I call it, this lexical block like we had before, and in it, I'm treating it as it's a subroutine. And then I'm passing in after that some strings. And if you note, after the closing curly brace here, there's no comma. And that's for a reason. That's to give it the look and feel of, like, say, grep or map. Okay. So what you do is you pass in some series of some list here, and then it gets rolled up into this array. And so what's happening within the subroutine that is actually running this code, it's capturing the code reference, and then it's running it with whatever's left over in the subroutine's input parameters. And so that's what that's all about. Now I've defined at the bottom this lexical block that is getting forced to be a subroutine ref to capture whatever gets passed in, and then it iterates over those things, and then it just prints it out. So the output here, when I run this, is over here on the bottom right here. It's literally just going to be printing out each of these strings one after the other. Okay. All right. So this also kind of, I wanted to show this because you don't have to necessarily just use prototypes to define what you want the parameters to get coerced into, like the Perl data types to get coerced into. I actually, and I'll show in a little bit, I've actually found it useful just to have like this utility function that all it does is it takes in a lexical block and then it returns whatever gets passed in, which is the code ref. And so that all that's happening here, and I made it pretty terse on purpose, but what's happening here is it is expecting a lexical block. It gets coerced into a subroutine reference, and then this shift is just going to be shifting it off, returning it into whatever I want. So this will give me this coerced block to code ref. This gives me just a quick utility subroutine where I can pass it any lexical block and then get out the subroutine directly, and then I can run it. All right. Now, prototypes that were originally intended to create for users, for developers to create their own keywords. And so this is on, I don't list it here, but this is on Perl sub, Perl.Perl sub. And it basically just goes through some common templates that you would use in order to get, be able to call your customized functions as keywords that you're familiar with. And I wanted to point out there's here is my grep, and this is going to allow you to create a subroutine that you can then call as you would grep or pipe. I'm not going to get into it too deeply, but I will show some examples. But you can handle globs, so that's what these stars are. The dollar signs are scalars. Anything after the semicolon is optional. So if you were to call, say, my link here and not give it 2 parameters, it's gonna fail. It's gonna be a fatal error. But if for my index you give it only 2 and not 3, it'll be fine. If you give it 3 things, it'll be fine. If you give it 4 things, it'll die. And this is another example just to show it's literally just any scalar. So you can send it in. This is a code ref to a function that you've already defined. And then the substring is just a string. So, but anyway, this highlights, I think, my point that the prototypes are literally declarative templates of positionally what you want to force the parameters you're passing into it to be. And this is just going through some of, this is most of them. I think I might have skipped some, but the ampersand we already saw, it coerces a lexical block into a code reference. The star, it accepts bare word, constant, scalar expression, type glob, or reference to a type glob. And so that's super handy, and I've got an example later. The @ it coerces a list of things into an array. And so if you have that, it's going to suck everything up. It's going to eat all the things. Similarly, the % does it, but it puts it into a hash. The $ is a scalar, and it could be any scalar. It could be a reference, like we saw before. The semicolon, anything after the semicolon is optional. Now, this is cool. I have an example, I think maybe coming up. Yeah, I do. And but if you give it an underscore, it tells Perl that you want it to, if no parameters are provided, it'll get $_. So then you can use it like print or chomp, those kind of things. I don't have any examples of this plus, but you can do some things where you can define like classes, like say this backslash @%. That is a way to tell Perl that you want, and this backslash also is a reference. So this backslash group notation, I have these out of order, but backslash group notation is to specify more than one allowed argument type. So this backslash open brace @% close brace will apply to the position that it's sitting in, but it'll accept, in this case, it'll act as an array or it'll accept an array or a hash reference. That's what the backslash is. Okay, now this is an example of how you would give something, a subroutine that you wrote, the ability to just look for the $_, like a lot of the Perl methods that we like will do. And so this is just, I'm just creating a my print. And now the prototype is just the underscore. So you can look at this as a dollar sign, that if you don't pass it a parameter, it'll look for dollar underscore. And this is an example right here, just using a while that's iterating over some standard, some file that you've catted in, or some standard input that you've set into the diamond operator. So it's doing just a chomp, and that operates on dollar underscore if you don't give it anything to chomp. And then my print, it doesn't say what it's printing, but it's going to default to printing dollar underscore, which is each line. And what I have here, I know this is kind of confusing, but I wanted to highlight, I am passing the Perl script, I'm running the Perl script, and I'm passing the Perl script to itself. And so it's literally just printing itself out here. And so that's why there's code here, even though I'm saying it's output. If I'm going too fast or y'all have questions, just stop me. Okay, now I wanted to recall that this list of prototype templates, this is all very interesting, and I encourage you to go to Perl sub, Perl doc, and look at all of this. But in my experience, my recent experience using prototypes and kind of pushing them, I think, to some limits, I have found that the most useful one is going to be the ampersand at. And that's what you would use if you wanted to create something that has the same kind of calling, the calling as grep or map. One thing, I'm not, this is the only slide I'm going to have on signatures, but I wanted to point this out. And I think everybody here knows that prototypes are not signatures. And when signatures were being developed, a lot of people were confusing them with signatures or prototypes. Then they were saying, we need to improve, we need to get signatures because prototypes are terrible for defining signatures. Well, hopefully, if you follow me up to this point, you can see prototypes were never meant to be used as signatures, and or be able to detect whether or not you send in the wrong number of parameters. But because it will fail if you send in too many or too little parameters, prototypes have been used a lot for that, but they haven't. And so people would use it for that, but then they would want actual, default unpacking of variables and all of that. As such, prototypes and signatures can exist in the same script. There's the only conflict is they decided that in order to use signatures, it would use the parentheses after the subroutine name, or I guess the attributes, to define the signature. So the code example I have here shows how you would actually use prototypes and signatures in the same subroutine. And what you would have to do is, well, I don't know if this is still the case, but I think it is. You would have to use feature signatures if you want to use signatures, or maybe there's a minimum version of Perl that you would use now.
About 36.
It's 36. Okay.
Yeah.
And so when you turn that on, you have to explicitly tell the Perl interpreter which one of these sets of parameters is going to be the prototype. And so that's why you would have this attribute syntax here, where it's just colon prototype $, which is expecting two scalars. And then this is the signature, the X and the Y, and that gives us the automatic unpacking into those variables. And so when you run this, I didn't actually, this code does work. I didn't add the output, but basically all you're doing is just adding 1 and 2 here. So it's going to be printing 3. So that's the difference between prototypes and subroutine signatures and how you would use them together. Okay. So the reason why I got interested in prototypes is because although I'm not a big user of try-tiny, I was really interested in figuring out how the author, the original developer of it, accomplished it. And I started looking at it, the source code, and I noticed that they were using prototypes. And it is, I can pull the source code up shortly. I may even have a screenshot of some of it, but it's kind of hairy. But once I started looking at it a little more closely, I realized that they were actually combining multiple subroutines that had their own prototype defined, and they worked together. And so I looked at I think after I have CGI Tiny listed here second, but it was not long after I realized how Try Tiny worked that I decided I had this thought to treat alarm signals as an exception. And so that's what I wrote Try Alarm, and I'll show that here shortly. And I did that by using prototypes, multiple subroutines with their own prototypes. So basically each block is going to be its own subroutine, and it's going to be defined. It's going to have its own prototype defined. So like in Try Tiny, try is its own subroutine, catch is its own subroutine, and then finally, I think that's the last one, is its own subroutine. And then my most recent one that I did was dispatch foo, which I'll show also. But I did the same thing. I just created a bunch of subroutines with prototypes that were defined to basically work together. So these prototypes, so these templates, these subroutine prototype templates are the ones that I've seen the most in other people's codes and in the ones I've used the most. I mean, yeah, you'll see like the $sign or the $sign or something like that. But in terms of like actual like interesting prototypes, these are what I tend to see the most. And so the first one, sub foo with just the underscore, I showed you the example that gives you a way to have have it by default consume $_. Sub foo, just the ampersand, that is just the simplest lexical block to code coercion you can have. Sub foo $ or ampersand at gives you more flexibility and actually introduces the grep or the map like keyword user experience. And then also along with that is the ampersand and then semicolon at, that gives you even more flexibility where you can send it just a lexical block or a lexical block and then other stuff. So the next thing I want to talk about is I shouldn't say a lot of the things I've seen on prototypes only talk about single subroutine prototypes, because I really haven't seen that much about prototypes. And that's interesting to me that people haven't really, it seems like people have not really leaned on them very heavily, even after all of this time. And so after seeing Try Tiny and then trying it myself by creating these like multi subroutine, I don't know what you call them, structures or calling idioms. I started thinking about this concept of these compound prototypes. And at some point, hopefully maybe somebody else will do it, or I'll sit down and do it and really look at the different combinations of multiple prototype subroutines you can put together to create some really interesting things. But my experience is that the prototyping a subroutine is interesting, but it gets really interesting when you combine subroutines that have prototypes. And the second point here, this ampersand semicolon at, this is like it's kind of like a universal block accepting accumulator where you can pass it in a lexical block where you can pass it in some functionality, some higher order functionality you want to go into the subroutine that you're calling, and then you can pass it in parameters or not. And I use that in Try Alarm, and it's used in Try Tiny. And so I mentioned higher order concepts here. I have a copy of Marcus J. Dominus, I think that's his name. I don't know where the book is at the moment, but I went and found in the book where he mentioned prototypes, and he mentions it in 9 different spots. And he uses them in his examples. But it was interesting to me that he didn't he never kind of delved into an interesting topic of what happens when you start combining these things. At least I didn't see it in the book. But of course, the book is huge, and he's a super smart guy, and he talks about a a lot of other stuff in there, so I'm not faulting him at all. But that affirmed my belief that this is kind of a fruitful area for extending the language. And so so anyway, where do I want to go here? So subroutines can insert. Oh, I don't have an example of this, but one of the things that I was playing around with doing is when you can combine subroutines that have prototypes, and you form, like, I guess somebody please correct me, but I think it's called currying, where if you in functional programming, where you could actually have like a series of function calls that kind of go from get rolled up from right to left, where the rightmost call gets turned into a list of things or a singular thing, and then that becomes the input for its neighbor to the left, and then it kind of just collapses on itself, and then the final subroutine call all the way to the left gets something that has been made up by this right to left execution of all the subroutines. And that's essentially what try tiny is doing, and that's what I'm doing with the ones that I created. But the subroutine marker thing is, I wish I would have had time to do an example, but as the execution of the subroutines is happening from right to left, and keep in mind, there's no end of line mark, semicolons. These are all like singular commands strung out. You can do interesting things like you're transforming the data as the execution is happening from right to left, and the subroutines can transform it. The subroutine that is being executed can transform it however it wants, or however you program it to do, and you can insert markers, and that's how I use it in try alarm, where so that I know basically what how to differentiate what should be the like if I want to set a timeout, or if I want to set a number of tries. And so it occurred to me that you could have some really interesting transformations happen from right to left. That's all. I wish I should have just had a code example. Okay. Well, this is what I mean by compound prototypes here. So I'll start with try tiny. Everybody's familiar with try, and this is the lexical block here. So within it is just die foo. This is from the Perl doc. So it's going to die right away and then immediately invoke catch. Well, what's actually going on here when you define this block is that catch gets executed from right to left. And so the catch subroutine is turning this block here into a code ref, and then it's just storing it. And then that's getting passed in as a code reference into the try subroutine. Now, the try subroutine has two parameters. It's getting the lexical block here that dies, and then it's getting a reference to catch, it's a code reference that was generated in the same way. And so it has to reverse it. So when a try executes with the subroutine that automatically dies, it already has tracked what it needs to do in catch before it even tries to execute what is in this lexical block of try. And here for dispatch foo, it's very similar. So dispatch foo, what it does is it takes you define all of these cases here using static strings, and then within the dispatch using the on keyword, and within the dispatch body here, this lexical scope code that gets turned into a subroutine, and then this input here gets considered with whatever is coded within this lexical block in dispatch. And the idea is you put it in a bucket, you classify it as some case. Like, so in this code, you would want to classify it as case 0, 1, 2, 3, 4, or 5. And so it'll evaluate it, but it rolls up everything starting from the very last on statement, and it builds up a hash table with the static strings case 0, 1, 2, 3, 4, 5. And so it knows this lookup table right away before it even executes what's in the dispatch block. It executes what's in the dispatch block. It's expecting a static string. And then it says, and then it just does a O1 lookup to the hash that gets built up, and it executes the subroutine ref that is linked to it. So I created this when I wanted to be able to have, I mean, I don't know if this is exactly like smart match, but I've always wanted to be able to have a dispatch table that was dynamic, and I could never figure out how to do it. But once I had my, the experience doing try alarm, and I was familiar with prototypes, I thought about maybe that's the right way to do it. And lo and behold, it worked out. I mean, I use this all the time in client code, and it has saved so much. Like for me, it saves so much coding and effort, and it's very clear. So this is something that I created and I actually use in production code. But the point is that it runs from right to left, and the whole time it's accumulating all of these on, whatever is defined using these on. The on is a subroutine. And so it's taking in, each one is taking in case, okay, and then it's taking in, this is a fat comma, and then it's taking in the subroutine reference. And the reason these are bare words is because this is a hash right here, a hash, yeah. And so I'm accumulating as each on subroutine is getting called, it's accumulating this hash of these different keys. Okay, so this is just a code snippet of try alarm. I have a link here if I need to click it, but I probably should, let me actually click that. Okay, I'm gonna bring this over here and show what's going on. First, let me go. This is how you would use try alarm. So the main, there's just a try once, but mostly when you use this, it would be your main, like the main terminal subroutine in this construct is retry. And so within this lexical body here, that's what you're going to be trying and potentially receiving an alarm signal before it's finished. And then this alarm here, you notice there's no comma between this close brace and this alarm. Alarm also is a subroutine. And this is where you get this lexical block defines the subroutine that is going to get set to be the handler if an alarm signal is detected. And then I have a finally here. That happens regardless whether or not ultimately you give up or not. After finally, I've got these two keywords here. And I'm not saying this is the best structure in the world, but this is I was pretty happy. And I do use this also, just not as much because I don't do a lot of stuff that times out. But this defines a timeout value, and this defines a number of tries that you want to retry. Okay, so there's retry, alarm, finally, timeout, tries. What is that? 5 subroutines. Okay, and so when you go to the code, timeout and tries is defined as okay. So how I have it set up here is if you call timeout without any parameters, it'll return what the timeout is. And here I have it up here as a package parameter. And then tries is the same thing. If you pass it something, it sets that as the timeout or the number of tries. Try once is basically just an alias or a wrapper around retry, where tries is just forced to 1. But retry this is the ampersand semicolon at, so you can just call it just retry with a block, and that's what that's for. And all this here, and you can see what I've been shocked at is the code, once you set this up, or once you kind of start working with prototypes in this way, the code is really short. The only reason I have all this stuff in here is because I started adding like, special cases. And so, but fundamentally, prototypes using it in this way allows you to write some very, very terse code, implicit code, but it gives you a huge amount of capability just from a few lines of combining these. So, but what I have in here is it just tracks all of the, it gets like the alarm. This is the alarm code ref. This is the timeout. This is the tries. This is the finally code ref. And so you can see I've got the default setup here. So alarm is just going to default to whatever sig alarm is set to. Retry. If you don't set it to anything, it's just an empty subroutine. Similarly, finally is just set to a subroutine. I mean, a blank empty subroutine. But all this stuff is literally just to manage. Okay, I've got the code I want to run to check in timeout. I've got the handler I want to use if it does timeout, and then I can set the number of seconds of timeout, the number of tries, and that's really all the rest of this code is. And although it is, I mean, it's a little hairy, but it's not a huge amount of code, which is pretty shocking to me. But you can see also we got alarm, how small it is. All it's doing is it's adding. I'm adding this marker here to say, okay, what follows after this marker alarm is going to be the alarm subref or code ref, and it just so happens I can. By doing this, I implicitly build up a hash. So I'm literally just adding a key in front of that lexical block that becomes the subroutine through this alarm, this prototyped alarm sub. And I do the same thing with finally. And then these are just some resertion things here. But you can see it's not a huge amount of code. And then dispatch foo, similarly, is not that much code. I am still shocked that it's not a lot of code to do these things that give you some really cool capabilities. Let's see, try tiny. I've got try tiny up here. You can see try tiny isn't that big. And most of this stuff, it's got a finally, it's got a catch. And like I said, I studied this pretty closely. And it really blew my mind when I understood how try tiny was working. And so that inspired me to do that. But you can see it's just defining those, try, catch, finally. They're all just subroutines with these flexible prototypes in place. CGI tiny is not a compounded. You really just define. I love CGI tiny. I also use this in production a lot. But you're just defining this subroutine, and it's going to be like an ampersand. Let's go to the code. Every time I click on it, I go to the pod, not the code. Where's that? Wait. Here we go. So this is the main function that you're calling, and it literally is just the single ampersand. And so it takes that lexical block you give it, manages it, and then runs it, and then it's got everything else in here is literally just to support dealing with HTTP. So it's really amazing to me that prototypes allow this kind of implicit small, power packed code to work. And I haven't benchmarked it, but it seems pretty fast to me. Like, I don't notice any slowdown. Okay, so went over that code, CGI tiny. Okay. Can anybody tell me what they think this does? So I've got here, this is a test function with a prototype with just an @ So it's like an accumulator. And then foo, it's got the star, which can be like a bunch of different things. And I'll give you a hint. I'm treating whatever I'm passing it in as a bear word. Which, if you were to look at and it's calling it here, test foo bar. Like based on these subroutines and the prototypes, this is valid Perl code.
I have
All right.
no idea what it does, but if someone sent this code to me, I would fire them. I'm just saying.
That's why you don't return my phone calls.
Yeah, hey, no, that's a different reason.
Oh,
well, is it because we're doing subroutine calls without parentheses?
Hey, that's like the least offensive thing of this entire slide I'm looking at. Mike.
Okay. Because I always do a double take whenever I have to look at, is that a
Why can't we just put test foo bar with no semicolon or any syntax or punctuation of any kind, and it will just be a whole language of bear words, why not?
Well, you joke, but I think this is possible.
But we're almost there.
Okay, it literally just prints itself. Well, not the whole code, but it just prints test foo bar, like semicolon. And I kind of cheated because I concatenated the semicolon here. But
boy,
I would not have been able to know. I did this last night as because I wanted to play with the star here, just to see what it does. But it basically gives you another avenue outside of hash keys to use bare words, which I thought was pretty cool. Okay. What is possible? Oh, wait. Okay. So I've also been thinking about this for a while. Now I'm not doing this for like good reasons, but I always wanted to write my own object-oriented like thing, and make it, kind of look like Moo or Moose or Corinna or something. And I just did this after fooling around with it a little bit last night, but I wanted to call it new. And then this isn't everything, but I thought
Perl 6.
I'm just kind of stuck on calling it new at this point. But I did get this working. And it has a has subroutine here, and it's taking advantage of the star bear word thing and the accumulator. And here it's returning everything. And then it's got this class subroutine where, again, it's star at, and then it does some things in here, but it blesses whatever gets sent in using this. And so I am not suggesting this is anything good here, but it is possible, and it runs, that you can define using just these two subroutines like this. You can define a blessed object with foo, bar, and baz in this way. Now I just have I had to use the main the namespace because I didn't have time to figure out how not to, but you can imagine this just is bear word has, bear word foo, bar, baz. And then, but the main thing here I wanted to show is that this foo here in all caps is a class name, and it's just kind of like hanging out there. It's not defined anywhere, but the reason why it's legal is because class accepts that through the star. And then I wanted to make it look a little cleaner and give it accessors. And so I this is how it would look if you use util H2O more, which has this is my module also, and it has a baptized method. Like it's like bless, but it allows you to have accessors right away. And so instead of using bless, I just replaced bless with baptize, and then that using the same. I think, no, it's not the same. It doesn't do subroutine references here, but I was able to just show down here that with this monstrosity, you could get a blessed object with accessors here. And this is where it dumps. That DDD is just actually that shouldn't even be working. They should have oh no, wait, here it is. This is where I imported. Anyway, it's just a shortcut to data dumper that I have in my module. But that's where you're getting this this var1 here, and it's just showing that it's blessed as foo. Now this _1 is just to disambiguate it from any other like blessed objects that you have through this module, but in essence, you have a foo. And if you have a foo class defined somewhere else and you import it, you instantly have access to everything that foo gives you. Okay. That's it. Thank you. A couple of points, and I might just end up reading these, but I think Perl prototypes offer a very rich and vastly underexplored and underutilized way to define keywords and interesting multi-block compound idioms. Try alarm, dispatch foo. I think that probably you guys could probably come up with some really interesting stuff, a lot more interesting than mine. But I don't see anything about it. I've never really heard a lot of people talk about it, or at least dive this deep into it. And I really did not dive that deep into it. So it's probably rich for like applying functional programming concepts and like, a quick example with the try alarm. The key thing for me, the reason I created it is because the key insight I had, and I think I was arguing with some people on P5P about it, surprise. But I realized that, you can treat an alarm signal as an exception. And so that's what kind of sent me on that path to write try alarm. And so, but I think that they're probably, and then for dispatch foo, I was like, I really want to be able to do static dispatching, but also be dynamic. So if you have something that you keep banging your head up against, I would consider sketching out a structure that you would want to see that's Perlish, of course, and in some ways idiomatic, but sketch it out first and then see if you can make it happen using compound prototypes. Because I think chances are you can, or with some small modifications you can. The process for me was to try that, and then I would see something didn't work, and then I would just kind of bang on it for a while until I could get it into something that felt Perlish to me and that actually did work. The other thing I wanted to mention is there's a lot of hand wringing on P5P that happens with wanting to like write all this code and do all this stuff for like keyword, pluggable keywords and all this complicated stuff. I think prototypes has mostly what we would need, and it's been in there since the beginning or close to the beginning. And the other thing is, I really do think I'm going, maybe not out of spite. If I can do it not out of spite, I think I might actually take a look at that, creating some kind of object-oriented syntax that is pure Perl, can work using just prototypes, and ends up giving you not just a blessed reference, but actually allows you to define a full module using that structure. I think it's possible. And I think it could just, it wouldn't be something you would have to release. It would just be, it would be a module that had some keywords in it, but it wouldn't require anything groundbreaking or earth-shattering to happen within Perl. So if I can get to where I'm not doing it out of spite, I'll probably give it a shot. The last 2 points, that ampersand semicolon at seems to be like the universal useful prototype template. So if you want to do anything, that's probably the one you want to use. That's at least going to give you some interesting thing. And then Tom Christensen's article, which I referenced in the slide, the first slide, is very interesting. It doesn't it talks mostly about what's wrong with prototypes, and I probably should go back and reread it, but it gives you a lot of really like good deep insight. And again, for those of you who aren't at the beginning of the talk, the whole reason, the whole thing that started me off on really considering prototypes as anything other than just some vestigial piece of Perl was his last comment in this article, which is pretty long, where he calls it what I call my talk, which is, he says, prototypes are just parameter context templates for implicit coercions. And then that made all the difference to me, and why I was able to clearly see the difference between prototypes and signatures. They're completely different things. So with that said, I'm finished. Any questions? Comments?
I've got a question because I'm pretty skeptical about any high magic features like this. And by pretty, I mean extremely. So, is there any case where you actually need to use this, or is this just another situation, like you've said, of trying to get more terse code written, which I could argue in a separate, sidebar that I don't ever want more terse code,
Well,
which means I don't ever want to use this feature.
there are real reasons and benefits that I use this for. And one, I'm going to pull up one where I showcase CGI Tiny and how nice it is to have dispatch foo in to dispatch. So I have spent many hours on client code cleaning up old school CGI code that is like just disgusting, very deep nest of if statements at the top of the CGI script just to dispatch it out to a specific subroutine. And I have completely wiped out any complexity in these things using CGI Tiny coupled with dispatch foo. Now, I don't have to use CGI Tiny, and in fact, I only use CGI Tiny on new things I need to write in these environments. But with cleaning up these, and I'm talking about hundreds of lines of just nested garbage, it really shrinks it down, probably on the order of 90%, and you can read it. So that for me is a real practical reason to use.
So all of that code that you're eliminating is code that is specifically meant to do the job of somehow handling prototype templating.
No, it's meant to conditionally dispatch based on parameters that are getting sent to the CGI script from, like, say, a user form.
And how do positional, or how does this parameter thing solve that?
The parameter thing solves that because I used it to create dispatch foo, which is what I use to clean up everything. So it's not, I mean, I can't claim that you would use this in production code, this concept, but it's I guess my main overarching point of this is you can use the compound prototyping in this way to create very useful and interesting modules that can save a ton of code, that can eliminate a ton of code, make readability much better, make maintenance much lighter. And so that's the point, is you would actually be, I hope that you wouldn't be using this in a CGI script, like the raw technique, but you would definitely want to, if you wanted to create like a structured like module, like the ones I'm discussing, then you would be able to enable that kind of approach, like that structure, using the prototypes. So it's like a lower level thing to enable higher level structured code. If that makes sense.
So is the elimination of unnecessary code the main real life example that you would put forth?
I've got the examples are the modules that I've talked about. Try Tiny, CGI, the CGI Tiny, although that's not compounded, but then
The
the
one
ones
most
that,
people use would be list util.
oh, is that one? Okay.
Yeah, it's pretty much impossible without it. So is the curry module.
Yeah, I love list util.
I didn't even know that. I should have said in the beginning that these are the only ones that come to mind. I need to look at that code, but
begs the question: why is list util impossible without that?
You basically couldn't implement block level functions that act like grep and map, say like unique or first or any that accepts a block and then an array as if it's grep or map or anything like that. So you can't do the common pattern of composing a grep with a map with an any with a whatever you want to. That's a very common thing I see.
Yes, I'm looking at list util and I can see what you're saying.
Yeah.
Yeah.
So Will, hopefully that yeah, I would definitely not just jump right in and start using this technique in a CGI script. That wouldn't really make any sense.
Yeah,
But
it's
providing,
certainly got a lot of limitations, especially there are a lot of invalid prototypes that you can make that the interpreter does not complain at all about that are totally useless, like double percent, percent at percent.
yeah, here's this is Tom's article. This is the archive.org link, but I think he even has, he says he points out some of those useless prototypes here that George was talking about. But yeah, I think what I mean, nothing within Perl is without its warts, but I have been absolutely amazed at how short the code is using this technique that can provide really, really powerful, interesting constructs. And that's really the overall point. And I encourage you to explore it.
Thank you.
Yes, sir. What else? Does anybody think that is anybody inspired to try this out? Or did anything surprise anybody? I'm interested in your thoughts.
Well, it
I,
certainly helped explain it. I mean, if that was one of your goals, I'm not sure that I would rush out and use it because I can't think of anything off the top of my head that I would use this for. Mostly because I try not to add keywords to the language, but yeah, if I ever really needed to, I would probably look at this first.
now that
I'm actually go
I
ahead.
looked at the curry module again, I actually see a way that you could implement double argument block functions very easily, like say sort, but that isn't a sort. So that's something I'm probably going to be doing soon.
Yeah, you for whatever reason I don't understand it enough to feel like I would or could apply it. And matter of fact, George just completely sent my brain on a totally different topic as to whether I could implement grep without function signatures
Yeah, it's certainly a fun
or
exercise
prototypes.
to implement a parallelized grep. That was the first thing I delved into prototypes myself for. It's very useful.
A parallelized grep.
Yep.
Yeah, when when I need to get back onto the OpenMP stuff here before the as we get closer to the conference. Which I probably should plug the Science Perl conference here shortly. But there might be an opportunity for me to use this technique with some interesting OpenMP powered constructs.
So whenever I implemented a parallel grep, that was when I learned about the cool trick where you can set in the parent to ignore sig kill, and then you can send sig kill to the entire process group, and it'll kill all the children. Then you can go wait on them if you need to.
Is it
Cool.
parallelized in list utils?
No, there's no parallelization code inside of listutil. I believe MCE has a helper, a parallelized grep implementation, but
I just don't understand why you couldn't implement a grep, why you couldn't write a grep.
It's providing the idiomatic interface. I think, and like for me, that's the main draw for me is you can write these functions that do something that you're used to doing, in idiomatic, common Perl, well-established patterns that is your own implementation. So it's not just that you write your own grep, it's that you can write your own grep that gives you the same interface as the Perl grep. And you can do a drop in replace with it.
Oh, as in the list before the function.
Correct.
Yeah,
Okay.
and you can compose them like you can do reduce map grep all on one line.
Mhm.
Yeah. So that's I guess that I haven't really emphasized that enough, is it gives you that same UX, like that same developer, experience as people tend to gravitate towards within Perl. The composition, the patterns, that kind of thing.
Yeah, it's very common with both Python and Lisp for people to be very used to doing things like that, list comprehensions of map reduce and filter.
Yeah, well, I remember doing a scheme, and the one of the important things that I learned in that, going through that and learning that language, was how to do all the tedious things that are given to you for free in languages like Perl. But then it also kind of corrupted me, because now whenever I see a utility in Perl, not unlike what you just, it to me it abstracts so far from the writing the tedious code to actually do something like that. Rather, the abstraction so far that I know I no longer understand what I'm doing, if that makes any sense. Because when you say a lot of people use grep in Perl, it's like a lot of people's favorite to use the list utils grep and all of that, and my instinct is always to write one before I use one that's already written.
That's not a bad instinct, but reinventing the wheel is also
A waste of
not a
time.
great
It
instinct
is.
either. It's like a two-edged sword, right? Like you can learn a lot and you can get something that's maybe more suited for your own purposes if you do it yourself. But if it's something that's more than a super basic thing, then it is definitely worth looking at what other people have done. I've definitely used list util like unique and a few things like that, but I don't use it every day like some people I think probably do.
I recently dabbled in it and realized there was actually a lot of stuff in there that was really stinking nice to have, and well enough written that you can remember how to use it when you go back.
Yeah, I rarely go a day without using any at the least. So, but
Yeah,
anyways, yeah, I've seen a lot of times where doing a code review, I've gotten pushback on doing multiple stage compositions on lists. And it just takes a lot of people getting used to it, realizing when I see block, block, block list that this is list context the whole way through, and that I need to actually read it from right to left to understand what's going on instead of left to right. So
and I think that underscores the benefit of getting into the idiomatic side of Perl. I mean, we all know Larry Wall is a linguist, and it was, written so that you could read it like, a written language. But what comes with that is the, I guess slang is one way to put it, but just the idiomatic, like phrasing and the things that a native speaker would be saying, and other native speakers would be understanding. And that Perl allows that. I'm sure there are other languages that allow that as well, but Perl, I mean, certainly, Perl allows
Well,
that to a much more like a deeper degree than I think Python or, most other common
well,
languages.
Lisp does.
yeah, and I
That's
had
kind of the
this.
creme de la creme of writing plain language code, is actually Lisp.
Yes, especially AutoCAD Lisp. But the thing that I've done to sort of keep peace in the valley with regard to the people I work with these multi-stage list greps, things like that, I usually insist, if I can, on a Perl tidy RC that will make sure that blocks end up being on multiple lines, so that it looks much more like a traditional kind of for loop to them, because that's what they're used to. Most people who are in Perl, they're in imperative mode all the time. And so when you jump into list mode of functional composition, they're shifting gears, and that's something that they don't necessarily like. But whenever you have it broken into those multiple lines, they can start to it feels a little more natural to them, and it doesn't seem to trip them up on review nearly as much.
I need to. I ran into an issue with that. Like Perl Tidy does not like dispatch foo, and
There you go, Will.
Is it because of all of the prototypes?
It's 1
it's
point for
because
Will.
well, it's because I'm trying to find. I thought I'm looking offline here. Like I have to use. It might just be in some production code, but I have to use. Like if you do, it's like behind a comment, you do like 3, back arrows or less thans, and then you can define a block in shorthand where you don't want Perl Tidy to touch it. And I usually end up doing that on a lot of stuff.
Yeah, there's
But
probably
is
a
it
few rules
because
you
of
can
the
put in
proto-
RC.
Well, it's because it's because it's got this is a hold on. It's because you get something like this, and like Perl Tidy does not know what to do with this, at least by default. And that's what
Yes, you have to configure it.
Yikes.
Yeah, you have to configure it to do the right thing with that. There's 2 different params you'll want to deal with on that. I'll send you an RC.
Oh, cool. Yeah, that'll be helpful. And so, but like George was you were talking about like keeping it simple and people not readily seeing it as a list context. Like it does, like for me in designing this, and then the try alarm is I was going for not a list context. So it was like, although it's being evaluated in a list context, people
doesn't
write
look
it.
like it.
It
Yeah.
doesn't look like it. People write it almost in a declarative way. So like, here's a synopsis for try alarm is you're right. This is what you want to retry and wrap in an alarm. This is what you want to happen if an alarm signals. And then this part is a finally block, which you want to happen. And it gives accessors to try how many tries you've tried, and then how many, what the timeout is. Oh no, this is just the accessor. But then afterwards, you've got these things here where you can actually define. And this is in lieu of being able to define in this context parameters. So like what I would have preferred to have done, and this is what I started playing with originally, was have retry and then have like open parens, number of tries, and then timeout, close parens, and then have this, and then have the alarm block, which is it's analogous to the catch, and then finally is the same as finally. But what I ended up going with was just at the tail end, just providing these in list context, what you want the timeout to be and the tries to be. So yeah, my approach is always pass it off as a structure, like a structured thing, and not necessarily as a list. Even though if you were, and it's even not even intuitive, I even have to look at it for a minute each time and say, okay, this is actually getting executed from right to left. And the whole time I'm accumulating these things. Once it gets to the terminal call, the retry, then I have to like reorder it, track everything, and then do things in the right order. So
Yeah, another thing you can do if you really want to make reviewers mad is print will accept a block for the file handle argument. As long as it returns a file handle, it's fine.
So
we should have a whole meeting on how to upset reviewers. That would be
Yes. With
I'm-
self-destructing file handles.
I'm already pretty unhappy at this point, but I already expected that because I knew Brett was going to be presenting. Anyway, this code is terrible. I do not like it, and my question is it's a similar question to the first question. Is this really the only way to do what you were trying to do? I mean, whatever, like for example, try alarm. That code you just had up, can you go back to that?
Oh yeah.
Is that the only way to achieve what you were trying to achieve? Or I guess, is that the best, is that the most descriptive way to achieve it with like timeout arrow 3, tries arrow 3?
I probably could, I mean, I probably could revisit it and but I did spend a significant, well, I shouldn't say significant. I spent a decent amount of time trying to figure out some other way to do that. And that's not to say that it can't, I mean, y'all could probably see a way to do it very quickly.
There is.
That's just how I did it. How would you do it?
I would use Damien's keyword declare because it's even more insane.
Yeah.
Yeah, you're fired. You
What's
said
wrong
I
with
would
using
use
Tad Walker,
Damien's
man?
blank, and as soon as you said I would use Damien's blank, that was pretty much the end of it right there.
Said keyword declare.
Yes. It's one of the craziest modules on CPAN, and it's beautiful, and I love it. I think I seem to recall it is what sort of trolled P5P into actually implementing the ability to extend keywords correctly.
Oh, wow.
There's a way to do it. I just don't remember it off the top of my head. You can make arbitrarily new keywords now.
Yeah, Paul Evans put something out.
Yeah. So and certainly the keyword API is going to be more performant than something like a prototype. So if you got to do something in a tight loop, that's probably where you want to go.
Yeah. Yeah, I'll have to keep an eye out on it. So, well, I actually need to run here. And before I run, I wanted to promote the science track. It has been officially accepted by the conference planning, the TPRF or TPRC planning committee, and they are planning on having an official call for papers on Monday, and then we're going to be having our call for papers shortly after. We're not going to be doing a big splash yet. Our information for submitting papers will be within their call for papers, and then we're going to be sending out targeted announcements to different like email lists and stuff like that. So, but I wanted to give an update on that. Will, Zachy, I, and other people in the Perl or the Science Perl committee have been working pretty diligently to get this. And frankly, I'm surprised they went with it, but it's going to happen. So I'm excited. And the other thing I wanted to say was, okay, so Wednesday, February 28th, I'm going to be starting up. It's going to be like a second meeting each month. It's going to be on the fourth Wednesdays, and I'm going to be talking about Distzilla, and it's going to be more like a Perl study or office hours kind of approach. We're still having we're still going to be having the Thursday meetings. I just can't make these very often, and Julian has graciously agreed to continue to run those meetings. And I'm in talks with Josh. He says that probably he can do it. The March meeting, March 14th, which is a Thursday, Josh is going to be talking about something, and he's been doing a lot of work with API clients and looking at Corinna. So I don't know, Josh, did you want to talk anything, like mention what you might be talking about?
Oh, well, I just have two small API clients that recently were written. And of course, I posted those in the Facebook group. One was just using Corinna to make an API for Pastebin as an example, pastebin.com. And of course, I ran into some things in there that forced me to do it in a certain way, which was different from what I would do it if I was using Bless. And then also an API for intellexer.com, which is like an AI intelligent lexer, I guess, is where they derive their name from. So you could send it texts from files or text, and it will perform different evaluations of it, like selecting out of it top topics or comparing text and a few sort of AI type things related to text, and their API documentation wasn't. They never are great. Rarely do you find one that's just plain and complete. But I did run into some issues with that one too, that I just had never tried to write one that way. So yeah, we can look at the code and you can see how horrible it is, and we'll probably try to turn that one into the first thing I ever upload to CPAN.
Awesome. Well,
Hopefully.
Your comment about never finding good API documentation or complete it's like, it reminds me of whenever I go out and go to a public bathroom. I've never found a public bathroom that's completely touchless. You always have to touch something.
Yeah.
I'm not referring to that, but anywho.
Yeah, you want to see some really crazy API documentation, look at Discord. Discord is the most horrendous documentation I've ever seen. You're almost better off, switching languages and using the ones they provide, because it's just it didn't have to be that difficult. Let's just say.
Yeah, I remember dealing with OpenStack's API. I remember a full third of the calls were essentially lying with regard to what they gave you half the time.
I wanted to write one for Discord that used IO async, a bot for Discord, and really the motive. One thing I use Discord a lot. Zoom is extra on my computer. I normally would just have Discord and an IRC client, but I really kind of wanted one for Discord that didn't use any event, that used IO async, and went digging into that, and it was this weird combination of WebSocket stuff and JSON messages, and it was just like three different things, and you half the time you can't tell where you're at in the documentation as to what it's supposed to be. So that documentation is murder. And the other purpose was for my son. My son, he does social media stuff, and one of the things that he does is, or I used to do, was manage people's Discord servers for them, and to earn a few bucks or whatever. And he's really good with Discord, and bots is something potentially very helpful for him. And writing custom bots, would be really fantastic for him. And so he actually inquired if I could do that. And I was like, well, let me look at the API docs, and I got started. And then I felt like Will looking at Brett's code.
Extremely disappointed in Brett.
Yes, definitely. It's his fault.
Maybe
Well, I do blame
write-
Brett for trying to get us onto Discord, so that does match with my experience so far.
We're 3 for 3 tonight.
I find Discord to be much easier and intuitive than Zoom.
I'm not getting rid of Zoom, at least as long as Julian's around and John.
Well,
can,
it's
will
John
donate it.
that's giving it, because I'm going to lose my channel shortly. So
Yeah, and if John gives it up, I'll get a Zoom account for us. It won't be a big deal.
okay.
I do not plan to participate in anything on Slack or Discord ever, just FYI.
Okay.
Why do you not like Discord?
I mean, there's a variety of good privacy
I've
reasons to
never
not.
used Slack, but Discord was just full of
Privacy
emojis
is
and
not
cartoons.
privacy is not part of Will's calculation. He does everything on Facebook.
Ah, I see. Well, yeah, I can certainly see the reason why a lot of people are turned off by both Slack and by Discord, because it does have a level of frivolity with regard to the communication that is not present in something like IRC, that isn't just spamming emojis all day.
I really just want to try out this streaming and maybe even stream on Twitch. We'll see. I mean, I just want to see how it goes. It might
I
be
have
terrible.
I
It
have
might be
streamed
terrible.
on. I've streamed on Discord. I've been in a Discord video conference like this with 4 and 5 people. It works as expected. You can turn off in the management settings of your channel. You can have it where people can't post images, and you can sort of control all of that stuff. I mean, it's a complete software, whether you prefer it or not.
Well, sure. I mean, it came about because, gamers use it to coordinate, right? I mean, ultimately, isn't that the original use of it?
Yeah,
So-
basically not everybody knew that Mumble was a thing, so they, commercialized basically a software package that was Frankensteining together Mumble and XMPP. I think it's
Oh,
eJeopardy.
wow.
So
Oh, interesting.
Well,
All right,
yeah,
guys.
I've
I need to
used,
run. Thank y'all for being here.
I'm going to
and I'll-
stop the recording. I will try to get it up
Oh, yeah.
tomorrow.